Hello everyone, and today it's time for doing a project. So today we'll be exploring a new data set, something really interesting, and it is really very interesting to work on this data set. So this is a penguin data set which we'll be exploring today. So open your Jupyter notebook, and this is how my Jupyter directory looks like. I'm working currently in this folder. So you can go and create a new Python 3 if you're working with Python, or R if you're working in R. We are working in Python 3. This is Python video. So you create one Python 3, a new Jupyter notebook would be open here, and rename it as Penguin dataset, and we start working. So I'll show you this. How does it look? We are working with this dataset. This is similar to iris dataset. If you've done this iris dataset before, I'll provide the link. In the task is to predict the species as per their dimensions, like whatever input we have about their flippers and their beaks, their nose. Depending on that, we will predict these three species, these penguin species. So you can see they're beautiful. And I'll tell you the name of these species. This is Gen 2. This is Gen 2 actually. This is spelled as Gen 2. This is Adeline, and this is crest chest strap. Okay, so just we'll come again and see their shape and size and the flipper length and width a little later, but let me explain you how what I did was how do you get this image in your Jupyter notebook. This is a separate video which I have done, how to load an image. You can go and access that. I'll provide the link, but for now, just the sake of convenience, what you do is from PIL import image. This is from image. I have taken this, and in an object image I have created this, that image.open. What is the name of the file? The file is already been loaded in my directory. So follow me carefully. What I did was I uploaded here an image from my screenshots, from my downloads, and I named it as penguin.png. You can see it here, and I am working in the same directory, and you call the, and your file is also in the same directory. Okay, penguin dataset. This is the open file, and you just call this penguin.png, whatever extension is there, and you call this image, and this will be loaded here. Now what you do is we'll come and I'll come and explain this thing later on, what these how to really understand and classify these images. First, let's understand how to actually start exploring the data, how to get the data. So where do you get the data? You get it from Seaborn. It is already imported and loaded in Seaborn. So you import this library Seaborn as SNS. This is the classic standard what we write, and also you import matplotlib because we'll be needing it for few plots, basic plots like histograms and everything. So import it as plt and run it. This is like we are loading the basic libraries. So you load libraries, okay, and now what you do, if you want to check the version of SNS in which you are working, so what you write is sns dot hash hash underscore underscore, right here version, again underscore underscore, and this is how you check the version. So I can just write here what I'm doing. I'm just check the version of Seaborn. Okay, so just do that. I'm converting into heading 3, and now we come to our data set. Now what I do is I will explore first of all the data sets of Seaborn. Okay, and how do I do this is, what I do is I tell SNS dot get, please get me the data set. Okay, I will not write please, but I'm just telling you that I will say that SNS dot get data set. What do I want? I want the data set names. So SNS, please give me the names of the data set. Hit shift and enter, and it will give you the names of the data set in a form of a list. So you can see that here are some around 3, 6, 9, 12, 15, 18 data sets which are there in the Seaborn, and I can work with any data sets. It is attention, brain network, car crashes, diamond dots, exercise flights, Fermi, Femri, Gammas, Giza, etc. So we have taken penguins here. Okay, I'm working with penguin dataset. Tips and iris are already being done. I think I have done Titanic also, but it has not been uploaded. I'll do that shortly. So let's do this fourth dataset, that is planets. Okay. Now what you do is we know that this data is there. Now we want to work with this data. How do I get this data in my Jupyter notebook? So what I do is now I am loading my data set in the Jupyter notebook. So you load the data set, the specific data set, and okay. So this is an error here because this is not converted to heading. So now you load this data in an object called df. This will contain my data, and here I will write sns.load data set. Which data set I want? I want penguin. Firstly, I loaded the data set names. Now I am loading the particular data, and I want to see only the first 10 entries. So I will just write show me the 10 entries. Now this is showing me the 10 entries of my data set. Like it is now, data set means it has been converted into rows and columns, and this becomes more easy to do data analysis and to plot this data because it is in a organized form, in a form of rows and columns. So I can just see the first 10 entries, right? Now if I want to see how many total rows and columns are there, so what I do is I will write df.shape. It will tell me that there are 344 rows and 7 columns. These are the columns: species, island, bill length, bill depth, flipper length, body mass, and sex. And also there are 344 rows. So if you want to check the last entries, you just write tail and mention just 5 entries here. By default it will give you 5. So you can see here that this index is 343. That means 0 is also included, makes it 344. Now I want to tell you one more thing, that you can see this NaN, this is the null values here. Okay, and you can also find the missing values. Okay, what's wrong with this? Okay, so now you can also find, I don't think something is wrong with my Jupyter notebook. It is not responding well. Okay, yes, got it. Bear with me a little. Okay, so now here you've got this NaN species. You've got it in various places. Now we will have to deal with it when we shall see how do we deal with this. But firstly, let us just explore this data set a little more depth and understand what this data is really saying. I want to show you something really interesting here. Let us just check the null values. So what I write is df dot is null dot sum, and I check that there are, like in sex you've got 11 null values, in body mass you've got 2, 2, 2. So you have got some null values here. Okay, now I want you to go through one more thing, that some statistical calculation if you do, we will just write here df.describe, and I will show you the transpose of it. What transpose does it? It converts the rows into columns. Now see this difference, and see the difference between when I simply write describe. And you can see this, that when I write only describe, I will get count, mean, standard deviation, the main statistical calculations in the rows, and the columns are represented here. But when I do the transpose, the rows are converted into columns. So this becomes more representative, as I can see this thing and I can interpret the results quite easily. And I find that the count is 342 for all, and the minimum I can find, the body mass is like, there's the body mass, this is the body mass, and the minimum is 2700 grams and the maximum is 6300. So I can see the range here, that it from 2700 to 6300, and flipper length again you can see 172 to 331. So there's a great variation here, and here also bill depth and bill length. So we'll see what does this mean and how to really link it with the diagram, link it with penguin. So now comes something really interesting, but before that I will also let you know something like, let's understand one more thing here, and let me tell you the data types of the Okay, our data types of the columns is like species, island, and sex. They are in object form, that means category, and rest of the 4 are in floating, that means in numbers. So before fitting in or giving it to the algorithm, we have to deal with these object type data types. Okay, remember this thing. Next thing I want to show you is something called data types. Okay, df.info. I want to show you df.info. What does this info mean? Now this will give me the entire concise summary of the data set. What is the summary of my data sets? And it is concise because it is giving me the index numbers from 0 to 343, and this is giving me the columns, the null count, that means how many entries are there which are not null, and the data type. So entire information I will get into df.info. I don't have to manually write everything here just like I was doing it here above from data.dtype and stuff. So I don't have to write here data.dtypes again and again. I can just get everything from this data.info. Okay, moving on next to, okay, now this is the interesting part. I want to show you one more thing. Let's just since I have imported already from pil import image, so I will not write it again. I will just write here from image1 and an object image1. I will store what image. I have again uploaded an image just to show you, and that is pic.png, and I will call this image. Okay, so this was the image that I had done already. I have uploaded this thing. So now you understand that this is a penguin, a cute penguin, little penguin, and we are dealing with the flipper here in the data set. We've got the flipper data, and we have got this bill length. We've got the bill length and we've got the bill depth. So we've got these 4 features here, and we've got the body mass, the weight of the penguin, the flippers, and the bill. Okay, now what I want to show you here is something which we have done before. Now let's just see these penguins. Now you understand this bill length and bill depth, and this Gento. This is Gento, and with its huge flippers, it's saying, "Yeah, live life king size." So this, you can see that its flippers are really big, and its beak is small as compared to chest strap. Here you can see the flippers, the size, and you can see that the weight also varies. That this chest strap has less weight, body mass, as compared to these 2 penguins. This Adeline is the little, um, hi dude, how are you types, a little less bubbly as compared to the Gento. I like this penguin really nice. And these penguins are being found in Antarctica and different islands in Antarctica. Actually, we explore this thing. So just have a view of these penguin, their size and their shape, and how do they really look, because I won't be coming up again to this picture again and again while we are plotting the data. So I hope these cute little penguins are being clear. Now let's go on to plotting and some more calculations. Okay, now what I do is I would let's just find the correlation. Okay, I want to find the correlation between different attributes, so I will write df.corr to find the correlation among the the object, I mean the integer values. So I see that the bill length and the bill depth, they are negatively correlated, minus 0.23. That means I do not find any positive correlation here. See, these are numbers. To find greater meaning in analysis, let's just plot it, and then we can just refer to number. First figure and then numbers. Okay, this is what I have heard somewhere. So I just copy that. CMAP I would use as magma, and I would write a note. What does this note do is it will give me the values inside of this matrix, Seaborn matrix, as you can see. And now you see this, the bill length and bill depth, they are negatively correlated here, and the flipper length and the bill length are positively correlated, 0.66. It is a good correlation. So I can say that the length of the flipper and the bill length, if it is greater, or if it is big, then the bill length will be big. If flipper length is large, then bill length will be large. This is what it is signifying. And what about bill length and bill depth? So naturally this will be a negative correlation, because if flipper length is big, then bill depth would be small. That is what negative correlation means. That means both the variables are moving in the opposite direction. So that's what flipper length and bill depth shows. And so the reverse is true for flipper length and bill length. Now we see this negative correlation again with the bill depth and bill length, but obvious, right? Then now if you see this body mass and flipper length, so if you've got big flipper length, your body mass tends to increase, and we have seen this in Gento penguins and in Edeline, that their flipper length was big and their body mass was also huge, right? Okay, so this was the heat map, or you can say the correlation map, which is telling me the positive and negative correlation of the data set. This is how you infer this entire thing. Now I'm coming to something which will show you the shape of the data. Okay, let's first understand the histogram, and I want to see the shape of my data. These are the basic things that we do for understanding the shape of my data set. What I do is I will write just like, oh no, I don't want this. I want to write df dot, I want a histogram, so I will tell that df dot hist, and what you do, you give me a histogram, and I will just set the figure size equals to 12,12, and remember histogram is being plotted for numeric data set, so I will just plot it for numeric data set, and I will tell matplotlib plt.show me the figure. So this is what my figure looks like. Okay, as you can see the figure, so this is bill depth, and you can see its distribution. You can see the bill length, body mass, and flipper length. So these are being plotted, and no, these are not I would say the Gaussian distribution, not bell-shaped curve, or this is it is varying in different intervals. Like if I can infer this, the bill length varies from like 20 to like around less than 60. So there's a huge variation in my data set. There would be a little outliers also, as I can see here, and in this bill depth I can see it also ranges from like around less than 14 to more than 20, right? This is how you can just infer, and since we have this description, minimum and maximum and 25%, most of the data lies here between like 17 to somewhere around 18.5, 19 something, like bill depth. Okay, now to make it more interesting, I would also tell you a few more things. Let me just show you a few more things here, and we'll plot some outliers. That means box plot. So we are going to plot something called box plot here. Let's just write here box plot. Okay, box plot shows me the outliers, and it just tells me how many correct this thing, I mean the spelling and the okay, it's taking a little time, just bear with me. Okay, so I can just do this fine with box plot. Okay, I just want to show you the box plot. So what happens here is you just write here df, and df dot what I want what is happening today, I don't understand. Okay, df dot plot, and in there you will write kind equals to, because the kind I will mention kind equals to box, and this box will come in quotes, because I'm specifying what kind of plot do I want here, either scatter or box or something, and I will tell it that I will want subplots equals true. This takes the Boolean values true or false, subplots. And here I also want to give you the layout. That means that how it has to be plotted, in how many rows and columns. And then I want something wherein I can just set this share x equals to false and share y is also false. So I will just show you this share x and share y as false. Both they again take boolean values. And another thing, the size. So let me set the size of this fixed size, and the fixed size could be equals to, again I can give it like 8,12, 12,12 depending upon your need. Do this, and then what you do is plt.show. That's why I've imported this matplotlib, so that it can just show you the plots. So now you can see this, the bill length, and okay, so here you go. I can just zoom out a little, and okay, so we see the outliers. Actually they're not outliers, but the spread of the data is much. I can see that there's a continuity in the data, but the spread is much here in bill depth also, and in bill length also. Flipper length is also like, there are a few penguin species who've got flipper length like around 230. That means they've got huge flippers. And the body mass also ranges around like more than 6,000. So again we can see that heavyweight penguins are also there. Okay, and there are penguins who've got body mass less than 3,000, and we have also seen that flipper length is also less for a few penguins. And we know by the image that chest strap is the one like mentioning here, but we have to see how to really visualize that thing. So let's just do it. So now I will show you one more thing, and that would be, let's just plot a few of the plots. I would tell you, and let's just go about the value count function. That is a very good function here in Python. Value counts function. Value counts help me to count the individual values of the data set, and I can just later on plot it also. So let's do this value counts. Okay, I want to see how many sex or how many islands are there, how many species count is there. So what I do is, in the data set, where do you go? You go to the column of sex, and then you just go and value count that value and give me the value counts of those. And it is saying that the male is 168 and females is 165. Now if you want to plot this data, which we will do so shortly, first let us just find out the value counts of all the object type of variables we have. Let us do it for islands now. So island dot value counts, and here we get, okay, we've got these 3 islands here: Dream, Bisco, and Torgerson. Okay, and in Torgerson we've got less values as compared to the other 2. Now if you want to find out the species, let's find out the species value count. So species dot value counts, and so you see we have got 3 species here: Adelie, Gento, and Chinstrap, and their respective counts. So 152 values species we have of Adeline, Gento is 124, and Chinstrap is 68. Okay, this is what value counts tell us. And since these were the object types, so we have just explored the object types. Now we want see, we have got the diagrams of the numeric data set with histograms and with box plots. What about the object type data set? So plot them, we will make use of count plots. Okay, count plots are helpful to plot the data types, object data types. And so I will go for count plots of SNS, which is kind of a histogram for categorical data. So what I do is I would plot count plot now. So I will plot one count plot, and that is like sns.countplot I will write, and I want to give the data as df. So you go, I'm specifying that you go to this data df, and I will give the x-axis. In x I want sex to be plotted, I want the palette to just make it a little more interesting. Let me take rocket here, and I'll take hue here, and hue would be species. Okay, so I'm adding the semicolon so that I don't get additional instructions. And this is what it looks like. So you can see that on the x-axis I've got male and females and with their respective species count. And Adeline is for males, it is like more than 70. Chinstripe for male is more than 30, and Gen 2 is like around 60 for males. Similarly for females also, we can just count the number of the respective species in respective gender. You can again experiment this count plot with SNS dot. Again, you can just experiment with changing this columns here. So again, just specify the data that you go to the data df, and then in x you can just mention here that okay, I don't want this, let me just take the island, and I want to see in which island which species is more. So if you just want to check the columns, just here write df dot columns. If you're confused, then you can just see that this is island here, and then right here hue we use to just mention this here. So I will again use species here, SPE, okay, species. Palette, what palette this time, guys? Let's take a different palette, and I would take a palette called tab 20, tab 10. Let's take tab 10. Okay, so I can see that in Togresen I've got Adeline, and then in Bisco Island I have got 2 species, and in Dream Island again I have got 2 species, and the color will differentiate it more nicely. If I take here HUSL, okay, this is much better, fine. So you can just experiment with different palettes here and see. If I have not included the semicolon, I get this matplotlib axis plotted. So if I don't want this command, I would just write semicolon, and you see the command is gone. Okay, so you can experiment here with different this thing. I have taken here island. What I do is I can just copy paste this thing, sns.countplot, not to write again. I will again experiment something new here. Instead of x here, I can just write the, okay, in island what are the different males and females. So if I would just want to plot it, and here I can give here as, autumn or summer. Let's write here summer. So you can just write here, you can see that males and females in different island, the count of that. So males are more, I mean, this is not screwed relationship, it is like almost equivalent males and females I can find in both the islands. And here from the above also I can infer that the Adelie species of penguin here in Togresen Island are almost equal in length, equal in number, which is more than 20. And in Bisco Island also the number of the Adelie and Gento species are almost similar. For males and females the number are almost similar. And in Dream Island also the Adelie and Chinstrap penguins, for males and females the population is almost the same. Okay, this is how what you can infer from this. So this is what Countplot tells you, the number and count. So what I do is I just double click on this so that it just goes. Now I just zoom it for you, and let's see more plots, more interesting plots. I want to show you one more thing here. Let's just SNS pair plots. Okay, so I would just tell you the pair plots. Okay, I wanted to convert it into a heading. This is right. So what I write is SNS dot pair plot, and what I write is data equals to df. I can write here hue equals to species, and then you can see the magic. And palette I can write here cool warm. Let's see what happens. Let's just check it out. It will take a little time, and here you are done. Beautiful plot. and you can see the correlation. You can also see the linear relationship if it exists among different variables. So I see the distribution clearly for Adeline, Chinstrap and Gentoo. Here, as you can see here, cool, warm. If I just want a more prominent color, let me give you autumn. Alright, this is not a palette. So we just want to check the palettes. You can just see the palettes, write a wrong one and they will be giving you all the palettes. So that is what I do. And let's just take some good one. Cube helix is there. Ascent, greens, which one do you want? Rainbow. I was taking autumn. Autumn is not there. So let's take ascent. Okay. Okay. Ascent. The first one I've taken. Let's see how what does it plots. Okay. Fair enough, it's fine. Presentable. So now this color clearly distinguishes and just tells me that these are clearly separable species and you can really determine them with their bill length, Adeline bill length, Chinstrap bill length and Gentoo bill length when it is compared with, when it is compared with the lust, this one, which you cannot see here right now. I don't know what is wrong with my Jupyter notebook today, guys. Sorry, but bear with me. So this has been compared with the flipper length. If you can see, this is the flipper length when compared with the bill length, and you can see that this can be easily classified separately with the bill length and the flipper length. So bill length and flipper length for chin strap varies somewhere around between 45 to 60, and here also you can just resonate with this. And flipper length for Gentoo is more, as it is lying here in somewhere like 200 and something, and the body mass is also more for Gentoo. As you can see, this large flipped species of penguin, Gentoo, and it can give you a good hug also if you want, because of its flipper's length and size. And then as compared to this chin strap, which is really small and has less body weight, and Adelie is a little bit moron type, Haidu type. So you can just infer all these things from the data. So just jokes apart, but this is very easy and you can distinguish and you can easily classify these species. You can get a rough idea that okay, Gentoo is having more body mass, more bill length, and the bill depth is small, and the flipper length is really big for Gentoo. And then second comes Adelie and then chin strap. Now we move on to different plot, and let's just hurry up, and I will just show you the Violin plot. This is a cool plot for SNS, and we've done this before also. Violin plot. If you want to access this entire sheet, I will be providing it in my website on GitHub link for the code, and also on the Kaggle site. All will be provided in description box, so you can see it at your own convenience as and when you like. But first, let's understand this data set. So in this Violin plot, I have to give x and y axis. So I'm giving here x as sex, and here I want to see the flipper length, whether it is greater for females or greater for males, and I write exactly the column name as it is, and here I tell it to go to the data df, and the size I give as 8. Okay, so this is the Violin plot. So I can give you a palette also if I want, but this is the basic that by default it gives you blue and this orange color kind of color, and you can see the male and female with their flipper length. So for males it is almost like consistent, but in females you can see that it greatly lies between 180 around to 200, which is most of the females are lying in this band. And For other females, you can see it from 200, 210 to around like 220 or so. Okay, so this is how you can plot the Violin plot and understand the data. Violin plot also tells you this inside the box plot. So it is a combination of, you know, kernel density estimation and the box plot. So another plot if I want to show you for box plot is, let's just copy this and let's see one more plot. Okay, and I can just change the variables. I can change the species here. I can write here for species, and instead of this I will write here not flipper length. See, this was flipper length, okay, and for the species, but I want to make it a little more interesting. So what I'll do is I'll add a palette here, and this palette will be red and or the red and purple. Okay, let's take red purple. Okay, so you can see the flipper length of various species, and as we can see that the Gen 2, now it is very clear and evident that this Gen 2 with big flipper length is having here on the greater side. Big flipper is the bill size, the bill length is also big, and the body mass is also good or huge for this Gen 2, so it can be easily classified. Okay, so a few things are very clear here. I can just write here Control V. Okay, and again, if you want to like see the body mass instead of flipper, and let's just check what we are saying, is it right or not, because it is right because we have done it so far. But again, to check it, let's do it again, and I'll change the palette, and this time I want some good colors, so I will just check this yellow, orange, and let's take red. Let's see. Okay, body mass is not thing. It is not an mm, I'm sorry, it is in grams. I have mistaken this thing. So now you can see this body mass. Okay, so the body mass is for males, and for females you can just see this. I have not taken here species. Okay, I can take here species. For species again, see, Gen 2 is on the always on the higher side as compared to chin strip and Adelie. Alright, so we are done with Violin plot, count plot, histogram, box plot, pair plots, and count plot. What else we have explored? We have taken here, I think, histograms also, box plot, image, explanation of this, and okay, box plot, pair plots. So this was it for this video, and in next we shall build a model of this entire thing and see what is the accuracy of a model with different algorithms and classifiers. So just a note that stay tuned for the upcoming second part of this video and start exploring this SNS library, and this has got some huge good collection of data sets, and we will explore more data sets like diamonds and car crashes. This was just the penguin, and it was more interesting because it is just similar to iris data set, so it is like a good data set you can work with for exploration and for more practice. So stay tuned guys, and thanks for watching.